Into Unit 7, Activity 1, Equations of Circles, as we begin our conic sections unit. Looking at circles first, something we should be familiar with, maybe not as much with the formulas, but we'll get right into this. Recall that the definition of the circle is a set of all points that are equidistant from a single point. We call this single point the center of the circle. The distance that all points are from the center is called the radius. Identify the center and radius for each circle. So that should be pretty straightforward. Center here is 0, 0. Easiest way to do it is just to count either horizontal or vertical from that center point. Same thing with this one here. I'm over 2 down 1, and it's 8 till I get to the actual circle, and left 3 down 2, and say I go up 5 until I get to a point on the circle. Number 2, here we have a circle that's centered at the origin with a radius of 10. What must be true about the distance from point O, which is the center, the origin, to any other point on the circle? So every point is going to be 10 units away from that center point. So I know that that has to be 10. Find the missing coordinates of point A and point D. Nice thing on those are right on the axes. So 10, 0, 0, 10. I know that I'm 10 units away. Look at point B. If the x-coordinate of B is 8, that means the horizontal distance between O and point B is going to be 8, and the oblique distance is 10. So that means I've got two sides of a right triangle. So I'm asked to find the y value. I don't know what that part of the coordinate is, so we can just set up the Pythagorean theorem for that one. We take the square root of 36, and when we have that, we would in the solving process, we would have plus or minus, but because I see that that's in the first quadrant, I know the y value is going to be positive for that particular point. We're also supposed to find E and F. So here I'm looking for the y value on part E. In point F, I'm going to be looking for the x value. Still setting up the Pythagorean theorem for both of those. Don't know the y value. For point E, it's down here in the third quadrant, so I know it's actually going to be the negative. And for point F, I don't know the x value, but I'm over here in the fourth quadrant, so I know that it's going to be the positive value. So we end up with some irrational answers for that one. Number 3, still have that point center, the center at the origin with radius of 10. Again, the distance of OP, so any point on there is going to have a distance of 10. Write an equation using the Pythagorean theorem that shows the relation between x, y. So now I'm going to make this general in the circle. So x squared plus y squared is going to equal 10 squared, because I can always make that right triangle as long as I'm centered there at the origin. Suppose the radius of the circle will change to 6. Write the equation. So all that would change is my hypotenuse instead of 10 would be 6. So now we end up with x squared plus y squared equals 6 squared. And now let's make it completely general. What if the radius were r? So as we noticed, the radius here was 10. It was 10 squared. Here the radius was 6. It's 6 squared. So if I were to call that r, we would end up with x squared plus y squared equals r squared. And there's number 3. The following displays identify the center and radius for each of the circles. So here these are both centered at the origin. Radius on this one as I count over is going to be 4. Radius on this one as I count is going to be 8. So from our little general equation, x squared plus y squared equals r squared, I can just put in the 4 squared, I get 16, put in the 8 and squared, and I get 64. Consider the following equations. For each equation, identify the center, radius, and list one point on the circle. So here, again, I have an equation. I'm kind of working backwards now from the equation. What's the center? 0, 0. Radius is the square root of 25, so 5. And then 1 point, you could really list any number of points. I just picked the one. I just moved 5 units right from the center. So it would be like finding this point right here for this particular circle, which would be at 5, 0. Next one, I end up with, again, centered at 0, 0. And here the radius is going to be 7. So 7, 0 would be a point on the circle. 0, 7 would be a point. Negative 7, 0 would be a point. 0, negative 7 would be a point. Those are some quick, easy ones to find. Here I end up with the square root of 60, which is an irrational number. It would simplify to 2 times the square root of 15. If we want to do the approximate, give a decimal for that, that's okay as well. And again, I'm going to move that many units to the right, and the y coordinate would just be 0, and I could go to the top or to the left or to the bottom as well. So there's number 5, or number 5. Number 6, now we're going to move our circle off of the center at the origin. The remainder of this activity will focus on finding the equations for circles not centered at the origin. So consider this circle, identify the center. I'm at 4, 1. The radius is 5 as I count again over from that center. Identify the 4 darkened points. So I don't know if they showed up on your activity, but I've got them listed there. We're just looking for the directly horizontal and directly vertical points from the center. So those are the 4 coordinates that we would have. As we look at that, as you look at the next question, I'm going to flip the slide, but it says it looks like the point 7,5 is on the circle. So over here, it looks like that point is on the circle. All right, 0.75 appears to be on the circle. What is the horizontal distance between the center and the 0.75? Explain you can find this using the coordinates themselves. So horizontal distance, if I look here, I'm looking for 7,5 is right there. So it wants to know what is that horizontal distance. So really I can count it, but I can also think about how can I use the coordinates. I'm really just looking at the change in the x values. So 7 minus 4, my distance was 3. Find the vertical distance. That's going to be the change in the y values. So 5 minus 1 was 4 units. So again, I could count that. Yes, indeed, that ends up being 4 units. And this we just said is supposed to be before the radius is going to be 5. So the actual oblique distance is supposed to be 5. And is it? It is. So when we go through the steps, it does verify that 7,5 is on the circle because the distance from the center is the radius, in this case, which was 5 when I traveled to the 0.75. Distance from is going to be something that we're going to be having to look at here because it's really just a Pythagorean theorem. If I think about what I just did, I took the horizontal distance, which was the change in x values, and then the change in the y values was the vertical distance, and that was supposed to equal, in this case, the radius, which was 5. So now I'm going to make it general. Instead of the 0.75, I'm talking about any point, x, y. Since that distance between the center and any point is going to be 5, it should match up that x minus 4 squared plus y minus 1 squared is going to equal 5. So that's just using the Pythagorean theorem. It's actually the distance formula, but it's really derived from that Pythagorean theorem. All right, so the distance between any point and the center must be equal to 5. Explain how the equation can be rewritten. So here I get rid of the radical sign. I square both sides of the equation. And we end up with x minus 4 quantity squared plus y minus 1 quantity squared is going to be equal to 25 by squaring both sides. All right, number 9. Now we've got this circle. Identify the center. So my center is at 3, negative 2 over 3 down 2. And the radius, as we count, either the horizontal or vertical from the center is going to be 5. Suppose P of x is any point on the circle, since the distance between the center, 3, negative 2, and any point x, y must be 5. Explain how this equation could be found. Again, using the distance formula, distance between any point x and our center, y, and our center y coordinate. And then we end up with that equaling 5. That's what our distance has to equal. And then again, when we square both sides, x minus 3 squared plus y plus 2 squared equals 5. Now when we look at this, we can start to pick out some things that are probably evident when we go back to this. Well, I can find the center, there it is. I can find the center y coordinate, there it is. And I can also find the radius. So we'll see if that holds true as we continue on. Use reasoning similar to 8 and 9 to find the equation of a circle with center at 5, 2 and radius of 4. Remember, this means that the distance between any point x, y on the circle and 5, 2 must be 4. Rewrite your answer if needed so it does not have a radical square root sign. So remember, there's our distance formula. If we square both sides, we end up with that. Now, I don't have two ordered pairs. I have 5, 2. The other ordered pair is just my x, y. So we know that that distance has to be 4. So 4 squared, we end up with the 16. And then x minus the x, which was 5, y minus the y, which was 2. So there's going to be the equation for the circle. You can plug that equation into Desmos. Desmos, you can plug in equations like this, and you can see the circle. If you try to plug this into your graphing calculator, remember your graphing calculator is set up with y equals. So you'd have to solve this for y, and you'd actually would need two equations because there's going to be a plus or minus. So it's actually easier to see and kind of judge for yourself if that really works by plugging that into Desmos, if you're so inclined. General equation, now we're going to make it very general. We're just going to use HK as the center. Any point is XY, and the radius isn't 4 anymore. It's going to be called R. So now we're going to have all variables in here. We don't have any numbers like we had up on top. But as we noticed, those are really just going to be our values that we picked up for point C and point R. So X minus H squared plus Y minus K squared equals R squared. So 5 became H, 2 became K, and 16 we found by really squaring the radius. So there's the R squared. So this is going to be our formula that we're going to be using for circles as we continue on. Because even if it's centered at the 0, H is 0 and K is 0, and the formula still works. It goes back to what we had previously on the previous examples. So this is the big equation. Probably want to write that down somewhere. So we've got it as our equation of a circle. All right. So now we've got two examples. If I know the center and I know the radius, I should be able to write our equation. Center for this one is at over 2 down 1. Center for this one is left 3 down 2. Radius as I count, I'm going to go over 8. Radius on this one, go up 5. So I can count those. And then I can just plug in those values into our general equation from the last slide. X minus 2 quantity squared plus y minus negative 1, which is really just plus 1, equals 8 squared, which we would write as 64. X minus negative 3, so x plus 3 squared plus y minus negative 2, which is, again, plus 2 squared equals 5 squared, which we would write as 25. All right, and the last one, we're going to go in the other direction. We're going to be given the equation, and then we're going to be asked these questions and also some points. So here is the first equation. Consider the following. For each, identify the center and the radius, then list 4 points on each circle. Start at your center, go up, down, left, and right. The distance of one radius to find these 4 points. All right, so this one, there's no x minus number or x plus number, so that must mean that it is 0. So the x value is going to be 0, and the y value is going to be 8. Radius is the square root of 4, so we end up with 2. And from the center, I go left 2, right 2, up 2, down 2, and those are my 4 points. And that would help me if I were actually sketching the circle, because I'm going to want to have some points on there. Part B, here's the x part of the center, here's the y part of the center, and then I can see I've got 49. So the square root of 49 is going to be 7. So I've got 3, 1, radius is 7. Again, I can go left 7, right 7, up 7, down 7. Next one, here it's x plus 4. So this value for the x coordinate must be a negative 4. For the y coordinate, it's going to be negative 2. And then the square root of 64 is the radius. So negative 4, negative 2, at the radius of 8. Left 8, right 8, up 8, down 8. And the last one, negative 4, positive 8, square root of 25 is 5. So there's the center and the radius, and then my 4 points. Right 5, up 5, left 5, down 5. We end up with those ordered pairs. So there's our activity on circles.